Xin kính chào quý anh chị, phụ huynh, cha mẹ học sinh và các em học sinh thân mến. Trong video này tôi xin giới thiệu cách và trình bày cách phân tích và giải một cái bài tập ATAR Physics trong chương trình Physics của Australia. Đây là câu hỏi số 16 trong đề thi ATAR năm 2025. A group of students design an experiment to estimate the value of g, the acceleration due to gravity at ground level, and to locate the center of mass COM of a non-uniform piece of wood as shown in the diagram below. So we see that this piece of wood, it has the length of 76 centimeter, and this circle black point is the center of mass. They drill a small hole in one end of the piece of wood to make the pivot here. Then attach the strong Y with a force meter to the other end. Here, this is the Y we connect to the right end of the wood, and the force meter here used to measure the tension which keep this wood to be balanced. They hung different mass small m from the end of the piece of wood and measure the tension T in the Y. Measure tension T with this force meter. So obviously, when a student study this topic, they know that this is a topic about moment and talk about equilibrium. The length of the piece of wood is 76 centimeter, and it had a mass of 257 grams. The distance d was from the pivot to the center of mass of the piece of wood. The angle between the piece of wood and the y was kept constant at 35 degrees. The results in the table below. With the mass going from 0.2 to 0.7 kilograms, the tension are these values, 5.3, 6.5, etc., up to 13.2. Taking moments around the pivot, they establish the following relationship. The sum of the anti-clockwise moment equal to the sum of clockwise moment. Therefore, tension multiplied with the distance r is the anti-clockwise moment. Distance r here is the distance from the pivot to the line of action of the tension. This is the tension force along the y, tension T. So this wire is the line of action of the force tension. Therefore, the distance r here drawn perpendicularly from the pivot to the line of action of the force is the distance that we use to calculate the counterclockwise, anti-clockwise moment. The two other clockwise moments are the moment of the mg. The way mg actually is the gravity that the earth pulls with mass m down. But the force that this small mass pulling the piece of wood down, we use the red color. This force pulling down, let's call Fd, it is equal to the mg. They are two different types of force, but they have the same magnitude. So we can say mg, the magnitude is the force, multiply with the distance from this line of action, which is the vertical line through this point, the point that we attach the small m to the wooden, piece. That distance is L, the length of the wooden piece, and it is 76 centimeter. Here, this is mg times L, and then big mg times d. Big M is the weight, the mass of the wooden piece, of course, and mg is weight. Its weight times the distance d from pivot to this gravity. So on the right hand side here, the two clockwise moment, and the left hand side is the anti-clockwise moment. By dividing the equation here by the distance r on both sides, we get the next equation, which is this one, dividing the distance r. This allows the students to graph the tension T against the hanging mass m and use the graph to estimate the acceleration due to gravity g, and to locate the center of mass, change to the green color, and to locate the center of mass of the piece of wood. Question A, calculate the distance r from the pivot to the y. Distance r from the pivot to the y. So we can see that this is a right triangle, một tam giác vuông, and this distance r is the opposite side to the angle 35 degree here at the corner. And we also have the length of this wooden piece, which is 76 centimeter, which is the hypotenuse. Therefore, we can use sine of the angle 35 degree equal to opposite, which is r over hypotenuse, which is 76 centimeter. Therefore, we can quickly calculate the value of r. Okay, let me write the solution here. Distance r. Okay, let's try it again. Sine of 35 degree is opposite, which is r over hypotenuse 76 centimeter, 0.0. So r is 76 times sine of 35 degree. Okay, please wait a second. I will open the calculator and get the answer. I need to change the unit for the angle to degree, not radian. Okay, 76 times sine of 35 degrees. 43.6. 43.6 is the answer, taken in 3 significant figure, centimeter. Okay, and we can also check my solution, of course, with this mark scheme. So this is the conversion to meter. This is centimeter, so we need to convert this one into meter. 0.436 yeah, meter. Question B, graph the tension versus the mass on the grid below. Include a line of best fit. So this is a graphing question. Câu hỏi này nó khá là hay. Nó khác với những câu hỏi truyền thống của chương trình Việt Nam của mình, tức là nó không có liên quan gì đến việc vẽ đồ thị cả, hầu như là như vậy, và chỉ là những câu trắc nghiệm theo chương trình Việt Nam. Ở chương trình này thì mình có cái câu theo kiểu thí nghiệm, thực hành. Mình có những cái data này, so we have these values. So to plot the graph, of course, we need to take the value from the table and plot the points representing each couple of value. For example, the first value, the mass is 0.2 and the tension is 5.3. The mass 0.2, okay. The mass 0.2 is here and the tension is 5.3. 5.3 is here. Therefore, we mark this point. Let me choose the thicker pen to make a mark. This point is the first point. In the, when doing the experiment, you are supposed to use the letter X to represent this point. Okay. First point, 0.2 for mass and tension 5.3. Second point, the mass is 0.3 kilogram and the tension 6.5. 0.3 here and 6.5. Oh, sorry. I think I made a mistake here. Sorry. This is not 5.3. We have 6, 7, 8, 9. So 5.3 between 5 and 6. This is 5.5. 5.3 is here. So the first point is this point. Oops, let's use smaller size. Like this first point. Okay, let me make a little bit down. Of course, if in A level we have error bars, but in ATAR we do not have error bar. Oh, sorry, it's 0.1, 0.2, not 0.1. 0.2 and 0.3 here. It is 5.3. Now the next point, 6.5. This point is 7, so 6.5 here. 6.5. And the mass is 0.3 kilogram. This is the second point. Similarly, we will mark the remaining like 4 or 3, 5 points. 0.4, 8.1. 0.4 here, 8.1. This is 7. Oops. This is 7. This one, 7. This is 8. This is 9. 5.1 is slightly greater than 5. This point, slightly. And then yeah, this is the next point. Okay, then 0.5 kilogram, 0.5 and 10.4. We have 11 here. 10.4 is close to 10.5. This point, 10.4, close. Okay, and 0.5 kilogram, the mass, close. This point, zoom in, close to 10.5. This point, there, that's the next point. They look kinda straight line, right? 10.4. Okay. Now 0.6 kilogram, 11.9, close to 12, which is close to 12. This is 12, so 11.9 is very close there, and then here at this point 11.9 there. Okay, and lastly 0.7, 13.2, 13 here, even in 13, so 13.5, 13.2 is here, huh? 13.2, 13.5, 13.2 here. Okay, we finished marking the points, 6 points on the data, from table. Now the question asks us to draw a line of best fit, huh? Okay, it looks better now. We need 3 point below like this. 2 point here below, 2 point here on top, above the line, and 2 other point, reside on the line. This is the best fit line that I can do, I think. Okay, best fit line. That's it, huh? And of course, we can even extend the best fit line to have the y-intercept. The y-intercept is here, huh? Use a different color. So this point is the y-intercept, and it looks like this is 1, this is 2, 2.2, huh? Y-intercept. The value is 2.2 Newton. Okay. Okay, we finished the question B, huh? Now we can keep doing the next one, question C. Calculate the gradient of your best fit line on page 23. Indicate clearly on the graph 2 points used in your calculation. Extract the gradient to 3 significant figures and include the unit of the gradient. We need to choose 2 points on the best fit line to calculate the gradient, and of course the 2 points must be far away from each other. So I will choose, let me zoom in, this point. This point, let's call it A, huh? You need to choose the 2 points which are far enough from each other and easy to read the value. So I choose the next one here. It accidentally coincident with the given point. Okay, this is the point B, and now I will calculate the gradient, huh? Gradient is rise over run. Let me write it, which is change in y over change in x, huh? Okay, gradient delta y over delta x. The y coordinate of B coincidentally is the value when the weight is 0.7. Just an accident, ha. Nó chỉ là một sự tình cờ trùng hợp thôi. Mình không cố tình mình lấy một cái value ở trên table nhé. Mình phải lấy một cái value trên cái best fit line 13.2. 13.2 Newton minus the y of the point A here, which is 5, ha. 5.00, 3 significant figure. Change in x. X of the point B is 0.70 kilogram. Taking to 3.600, okay, and x of this point A is 1.8, 0.18, 0.180. Okay, now use the calculator to find this gradient. 13.2 minus 5.00, of course, and then divide 0.700 minus 0.180. We have this gradient 15.8. Okay, 15.8. Of course, rounded to 3 significant figures. Okay, let me check the mark scheme. Of course, if you provide a range, nó sẽ cho một cái range 16.6 cộng trừ 1 nhé. Cộng trừ 1 có nghĩa là cái minimum sẽ là 15.6. Và maximum là 17.6. Như vậy là cái value mà thầy tính ra ở đây thì nó agree, it is in the range provided by the mark scheme. Okay, and of course the the unit of the force is Newton, and the unit of the x here is a kilogram, so we can conclude Newton per kilogram is the unit of this gradient, huh? Okay, of course you need to show this calculation in your answer. Okay, let me cut the solution down here. Here. Yeah, let me move the thing, the unit here. Newton per kilogram is the answer. And do not forget to write the final answer, 15.8 in the blank space, huh? Newton per kilogram. You can also convert the Newton into the SI unit, which is kilogram for mass, meter per second square for acceleration, F equal ma Newton second law, huh? So when you multiply kilogram with per kilogram, no more kilogram, so the equivalent unit is meter per second square, which is the unit of acceleration, huh? Meter per second square. There. Okay. Question D. Use the calculated gradient from part C. Estimate the student experimental value for G. Give your answer to two significant figures. To answer this question D, we need to go back to the initial equation. Up here, let me take a screenshot of it and put it, down at the question so that we can analyze it. Oh, sorry, not this one. Sorry, please wait a second. Huh? Let me use a different software to take a screenshot. Okay, take the screenshot of this one. Question 2. Copy it and put it down here. Okay. Now we need to calculate the gravitational acceleration G, huh? From this equation, we can see that G is in the gradient. So because the mass m is the independent variable, so let me put the m behind, and other things GL over R in the front, and then the second term, we see the dependent variable T, the tension, huh? M here is independent variable on the x-axis. Cái đại lượng ở trên trục x, trục nằm ngang, gọi là trục hoành, thì nó là independent variable, còn cái đại lượng ở trên trục thẳng đứng, trục tung, thì nó là dependent variable, ha. The second term m g d over r is the y-intercept. So this equation looks similar to the y equal mx plus c, where c here is the gradient, the y-intercept, but we need to find the g in this expression. In this question related to the gradient that we calculated, and the whole thing here, GL over R is a gradient, huh? So let me write that gradient. The gradient is GL over the distance R. And that gradient, we've got the answer from question C is 15.8, huh? So we need to find G. So G is 15.8 multiplied with the distance R here, which is I will take the original calculation without the rounding, 76.0 times sine of 35 degree. Đó là cái kết quả từ câu A nhé, nhưng mà mình hạn chế rounding nhiều lần. Mình viết nguyên gốc của cái calculation để mà avoid cái over rounding. Multiply with R here and then divide the length. The length is 76 centimeter, huh? So the 76 you see they cancel out, of course, and then use the calculator to get the answer, huh? 15.8 times sine 35 degree. 15.8 is our gradient, okay, times sine of 35 degrees. And this is my answer, 9.06. 3 is in the figure. 9.06. Okay, so we see that this value is quite different, about 10% different from the renowned value 9.8 meter per second square, huh? It is totally fine because in reality, sometimes the experiment is not as accurate as we expected. Oh, sorry. Okay, let me write again. Brilliant here. Ok, mình check answer nhé. 9.5. Nó nói 16.6, còn của mình là 15.8 cho nên là nó chênh lệch khá là nhiều. Nhưng mà nên nhớ là cái chỗ gradient này lúc nãy nó cho một cái range cộng trừ 1 nhé. Tức là cái minimum là 15.6 lần. Tức là cái level của mình là 15.8 thì vẫn là ok. Nó vẫn nằm trong cái range đó. Thì tất nhiên là bên dưới này thì nó cũng phải có một cái range của cái G ha. Ok. The last question E. Use the line benefit from part B on the page 23 and the value of G found in part D to calculate the distance D from the pivot to the center of mass of the piece of wood. Distance D from pivot to the center of mass. Okay, give your answer to two significant figures. Now we need to calculate D. Here on the diagram of the experiment, D from pivot to the center of gravity. It is this distance D here. And to calculate that D, we will use the y-intercept of the benefit line. This part, the y-intercept, and that y-intercept, as I indicated here on the line of benefit, is 2.2 Newton. Okay, so now let's finish this question. That thing mgd over r equal to the y-intercept, which is 2.2 Newton that I indicated. Okay, now we need to find D. D is this y-intercept 2.2 multiplied with r here, which is 76.0 centimeter times sine of 35 degree. Okay, times r, and then divide G and m. And we take the value G from previous question, which is 9.00506 5.06 for G, divide G here, and then divide M, the mass, 257 gram, if I remember correctly. I'll check it again. The question, the mass of the wooden piece, 200 and here 57 gram, 257 grams. I need to multiply with 10 to the power -3 here to convert that into kilogram. The distance here, 76 centimeter, I need to multiply with 10 to the power -2 to convert this centimeter into meter, or I can remove it and write 0.76. Okay, remove this one. Use change it to the SI, the standard unit. Okay, 76 meter here. Okay, do this calculation. 2.2 y-intercept multiply with 0.76 and then times sine of 35 degrees, and then divide the radians 0.06 and mass 257 times 10 to the power -3 converted to kilogram. With the answer, that distance is 0.412 meter, which is 41.2 centimeter. It makes sense, It is smaller than the length of the wooden rod, which is 76 centimeter. Okay, so we finished this question, Đây là một cái bài tập điển hình phổ biến liên quan đến thí nghiệm, liên quan đến vẽ graph benefit line, và thông thường ở các cái năm thi khác thì nó cũng là những cái bài về cơ học mechanics như vậy.